Hey Lucy, so we're going to look onto z-scores now, okay? And z-scores will help us get the probability of getting like below a certain, I suppose, mean. Okay, I'll show you what I mean now. So here's a normal distribution, okay, and here's the mean. And all along we would have said, here's the mean plus 1 standard deviation, here's the mean plus 2 standard deviations, here's the mean plus 3 standard deviations. And we know that the mean plus 1 standard deviation is there's 34% of a chance of, I suppose, a certain number of data being in here. Okay, so remember we found out that 68% of the population will lie in here, okay, or the sample will lie in there, okay, between 1 standard deviation either side of the mean. And then 95 will lie within 2, and 99.7 will lie within 3. Okay, and this would have been the mean, and this would have been the mean plus 1 standard deviation, and this would have been the mean minus 1 standard deviation, and so on. But now we're going to change these means and mean plus 1 standard deviation and mean plus 2 standard deviations and mean minus 1 standard deviation, etc. into z-scores. And z-scores will help us find the probability of getting, maybe, if I pick something at random from this population, the probability of it being, with maybe in here, okay, or here, okay, whereas with the empirical rule, all we know is the chances of it being within 1 standard deviation of the mean, and within 2, and within 3. But with these z-scores, we might be able to find out, maybe if it lies within 1.5 standard deviations from the mean. Okay, so we can actually find out the percentages within the whole system. Okay, it'll make more sense as I move along. But what we have to do is we have to translate these into z-scores, okay? Because all we have here is mean and standard deviation. So we need to translate these means and standard deviations into z-scores. And here's what we do. We take our number, we take away the mean, and we put it all over standard deviation, and we get our z-score, okay? And then the probability of these z-scores, we just read them off the log tables. They're on page 36 and 37 of the logs. So if you want to get your logs and just have a quick glance at it, it will probably make a little bit more sense if you have that out in front of you. Okay, mine is in school, unfortunately. The best thing I can do is show you from the book, because they give a really good example. Okay, so what they say here, and it looks more complicated than it is. So what they say here is milk cartons are designed to hold 600 milliliters of milk. Okay. Their capacities are normally distributed with a mean of 600 milliliters. So the mean, or the average amount that a carton of milk holds, is 600 milliliters. And the standard deviation is 10 milliliters. Okay? So now we know the mean and we know the standard deviations. It says calculate the standard scores. These are the z-scores. Okay? Standard scores are z-scores. So calculate the standard scores for these capacities. Okay. Once we get the standard score, it'll be very easy then to get probabilities from them. Okay, but we'll just stick with this first. So they give us the mean, 600. They give us the standard deviation, 10. And we want to calculate these z-scores. Okay, well, here's what we do. There's our formula. And that stands for mean, and that stands for standard deviation. And all we do is throw it into our formula. So as you see, there's our mean. There's our standard deviation, and there's the number that we're being asked about. We're asking to find the z-score of this. And if we do that, we'll get a z-score of 1. Okay? Again, over here, there's the mean, standard deviation, and there's our number. And there's a z-score of minus 0.5. And this one here, the 625, well, mean, standard deviation, number, 2.5. And then it says mark these z-scores on the diagram of a standard normal curve. Okay, well, we know that a z-score of 1 is here. Yeah, it's exactly on 1 standard deviation above the mean. Now, minus 0.5, so again, minus, it's a half a standard deviation back this way. And 2.5, well, that's 2.5 standard deviations up here. Okay, so that's a z-score of 2.5. What it really is 2.5 standard deviations above the mean. Okay? And what can you conclude about the carton containing 625 milliliters? So 625 milliliters is the one up here. Well, the carton containing 625 milliliters is most unlikely, as the capacity is over 2 standard deviations above the mean. This is outside the 95% limit. Okay, so what we know here is it's very unlikely we're going to get something up here, because remember we said within 2 standard deviations there's a 95% chance that the data will be in here. Okay, so it's very, very rare that you're going to get a carton with 625 milliliters. Okay.